I would say one of the big things that most machine learning folks have is a lot of scar tissue around getting burnt by machine learning algorithms. One of the things that you learn is, oh, this algorithm has 99% accuracy. Awesome, I cracked it. And it's like, no, you didn't. You broke it. You put data in that it wasn't supposed to know. And constructing the problem of how you ask a machine learning question is a really hard thing to do.
Welcome to the Software Misadventures podcast, where we sit down with software and DevOps experts to hear their stories from the trenches about how software breaks in production. We are your hosts, Ronak, Austin, and Guang. We've seen firsthand how stressful it is when something breaks in production, but it's the best opportunity to learn about a system more deeply. When most of us started in this field, we didn't really know what to expect, and wish there were more resources on how veteran engineers overcame the daunting task of debugging complex systems. In these conversations, we discuss the principles and practical tips to build resilient software, as well as advice to grow as technical leaders.
Hey everyone, this is Ronak here. Our guest in this episode is Estola. Evan is a director of engineering at Flatiron Health, where he's leading engineering teams focused on building machine learning products. Prior to this, he was a lead machine learning engineer at Meetups building recommendation algorithms, and before that, he worked on hotel recommendations at Orbitz. Guang and I had so much fun speaking with Evan. Throughout the episode, he shares various stories when recommendation systems did not work as expected, like this one time when members on Meetups saw mathematically worse recommendations for meetups near them. He also shares why Schenectady, New York pops up on some lists of most popular cities, and the story behind a Wall Street Journal article about Orbitz steering Mac users to book pricier hotels. We also discuss skills Evan looks for when hiring ML engineers, how to give constructive feedback, filter bubbles, and much more. Please enjoy this highly entertaining conversation with Evan Estola. Evan, super excited to talk to you today. Welcome to the show.
Thank you very much for having me.
So you're a director of engineering at Flatiron today, and you've been working on machine learning systems for majority of your engineering career. Can you tell us about how you got started into machine learning?
Sure. So I think my path into machine learning has a lot of overlap with my path to becoming a software engineer at all. I was like a math kid. I loved that side of school. And I was never really a programmer. I didn't get exposed to it super young or anything like that, but I did get exposed to like open source and Linux type stuff. So I was used to like tinkering around on my computer. And I initially went to school for biomedical engineering. And when I was there, I made some friends, some lifelong friends, people that I'm still good friends with to this day. And they were computer science majors. And not only that, but they were taking a data mining class. And they told me about data mining, and I was like, that's the coolest thing I've ever heard of. Like, why wouldn't I do that? And so basically just switched over soon after that and have been pursuing that ever since. For listeners who are younger and have never heard this old-timey term data mining.
Yeah, I think it'll be great to explain that.
I think data mining was kind of, it involved machine learning techniques, but was really about any sort of systematic approach to using data sets to help make business decisions or anything like that. So it was a very sort of pragmatic angle into using data and into the machine learning world. And so that's what sort of sparked me from the very beginning, was not just the tools and the algorithms and all of that, but also the use of it and the sort of business or whatever you want to apply it to. Mm-hmm. I spent a lot of time in undergrad working for a information retrieval lab. I think there's a couple different ways that people get into the machine learning space, or there's a couple like types of labs that became machine learning labs. Like everybody's machine learning now, but yeah. There's the sort of AI side, and that has all this history from the 80s or whatever, and was not always using machine learning type approaches, but some of this like, fancy knowledge stuff or even the old school like chess algorithms, all using sort of knowledge bases and this sort of thing. But those groups got moved towards machine learning, or rather are definitely calling themselves machine learning. Well, I guess AI is cool again too, but whatever. I came from the sort of information retrieval side. So I think that how that changes the way I look at things is it's always practical. It's always about impact in a business for a customer, for a user, whatever. Not to say that people coming from the other side don't do that as well, but I think that's always been the lens that I looked at applying machine learning through.
That's pretty cool. So you mentioned a little bit about the math background, and actually, I've heard different aspects from different people I've spoken with. Some will say that, hey, to do machine learning effectively, you need to understand math. Whereas a lot of folks these days today, a lot of folks have the title of machine learning engineers, and some of those will say that, well, you need to know how to code, and having a CS background is, if not the same, maybe a little more important than having or understanding all the math behind it. I'm curious how much of machine learning these days is math versus CS, or it depends. Like, I'm just curious to get your thoughts on this.
Yeah, that's a great question. So I loved math. I'm not sure I was good at it, or rather, I thought I was good at it until I got to college and met people that were actually good at math.
Oh, that's all of us.
People that could just think in math.
That's all of us.
People that could just think in math. I was like, okay, I'm not. I guess I'm not a math person anymore. But I still like math. I think an interesting thing is you can never know all the math, right? Mm-hmm. So when I was first learning machine learning stuff, the math we did was all linear algebra, discrete. And now with, deep learning type stuff, it's all back to continuous calculus, differentiable functions and all this sort of thing. So you're never going to know all the math. You're never going to know the math that you need to know next. I would argue that you can never know too much statistics. Okay, maybe you can know too much statistics, but unless you're a statistics person, you can never know too much statistics. And so, especially working in a business, and you're often going to meet people with different backgrounds and need to explain things and need to just to figure out how confident you are about something. The stats is always useful. So in terms of the engineering side, when I started out, and I could probably tell a bunch of stories about how old I am or whatever, but when I started out, you had to really know a lot of engineering to do any of this stuff. So we were rolling our own Hadoop clusters, and the amount of engineering that it took to process large amounts of data was pretty intense. Nowadays, the tools have gotten a lot better. So there's a lot more space for folks that are coming in just on the either math or the sort of product plus ML math or whatever. So I think there's a lot of valid ways to get into this, and we kind of need everybody coming from all these different angles, and you're never going to know everything.
Yeah, that makes sense. So I assume you would be spending a lot of your time hiring, being in this position that you are. What sort of skill sets do you look for when you're interviewing folks? Is it depends on the kind of role you have on the team, you would index on one side or the other, or you're looking at the candidate holistically?
I think it depends. I think it's a bit of both. So sometimes we find people that are just great and seem like they're excited to work on hard problems, and especially one great thing at Flatiron is we are always looking for good communicators. We work in such a cross-functional space that communication and being able to explain things and being able to explain hard concepts, always super, super useful. Even back in my Meetup days, we had a pretty small team, and so some of the things I always looked for in engineers are, especially on the ML side, someone who can approach a problem from a problem-solving angle and not I want to use this cool algorithm side of things. We'd kind of set up our interview questions to get people to give us a naive approach first, just use search, or just use, just do rank by most popular. Don't go right to doing the craziest algorithm, because that first thing might work pretty well. And so it was always about sort of problems first. And then, especially at a small company like that, being able to communicate with product team, being able to communicate with the CEO. I always joke that I think, maybe we'll talk a bit more about interpretability later, but I always joke that the CEO problem is if your CEO gets a bad result from one of your algorithms, you better be able to explain it.
Yep.
Because he might come right over to your desk, especially at a small company.
Oh yeah, they would be the best QA people a company could ever have.
Kind of, but they're also kind of the worst, because the CEO has the weirdest data. They use the product for the weirdest thing.
That is true.
They're not a normal user.
Yep. This conversation is getting a little bit too real for me, but let's continue.
It's I understand that you're thinking of machine learning as a means to an end instead of just thinking of like, hey, I want to use this cool algorithm. In terms of just working with the product itself and, like you said, communicating with people, how do you think about learnability or teachability versus someone who has tons of experience coming into the job? Like, how do you balance that?
Yeah, that's a great question. I think in our industry, anybody that has a lot of experience has learned a lot of stuff. Being a computer scientist is kind of being a permanent learner. You know, like I said, you never know all the math. You're never going to know all the software packages. You know, when I talk to people that are trying to get into the industry as a whole, that's the main thing I tell them is you just learn how to learn things, because you can check every box on a resume or on an application in terms of the tools that you think you need to know. You're never going to know, even once you get there, even if you know all the packages they use, you're still not going to know that code base. Everywhere you go, you have to learn. And so I definitely think that that's a key aspect, but that's not to say that people who have a lot of experience, they've probably been through a lot of those before. So,
Yeah. And you also mentioned that from a machine learning perspective, it's a lot more about practice and how it can help the business. Like being a director of engineering where you are very close to the management and the business, I would imagine, than as compared to being an IC. How does it help you see the business aspect a little more closely? And how does it help you influence some of the decisions you make in terms of like the direction the team is taking?
Oh yeah, great question. I love working with the business. I love working with my product partners. I love working with all the different cross-functional folks. Now that I'm in health tech, we have doctors and other clinicians, and it's really a whole range of people that are influencing things. I always love when I love working on problems that are complicated enough that knowing a technical solution or knowing a different technical approach changes the way you approach the problem. And so being able to get engineers who want to understand the problems we're working on and can work cross-functionally and come into something and say, hey, actually, I know this technical, there's a possibility that if we look at it in this different lens, we can solve this problem in a way that a non-technical person never would have come up with. And so I love kind of bridging that gap. And that's a lot of what I do now in my role, is just helping to frame the business problem, helping to communicate technical things to non-technical people, and really connect smart people to hard problems. That's my favorite thing to do.
That's really cool. And how has that changed from your last job working at Meetup? Because to me, one of the benefits of working in like a deeply technical field like ML or engineering is that it is somewhat independent of the domain itself. Obviously, to excel at it, you need to have a lot of domain expertise, but it's usually not a prerequisite to get the job in the first place. Was there a steep learning curve that you felt like you had to kind of go through when you first joined Flatiron, or what was that like?
Yeah, that's a great question. So this is a question that's near and dear to my heart, because obviously a huge part of what I do is onboarding people into Flatiron, and absolutely it's a steep learning curve. And we don't look for, if we only looked for machine learning experts that also have NLP application and also have a knowledge of cancer genomics, like we probably wouldn't find many people. Luckily, there are a lot of people that have an interest in it. Like I like to joke that Flatiron probably has the highest percentage of people who thought they were going to be doctors and ended up as computer scientists or statisticians or whatever. I think we have the highest percentage of those people in the world. Not that everyone at Flatiron comes from that background, but having some sort of interest in the biology side and the medical side helps a lot, because there is a lot of just terminology to learn. I mean, the first few months onboarding at Flatiron is just learning a bunch of, not only learning that tech that we were talking about, learning the tools we use and all this stuff, but also just learning all these medical concepts. It's a challenge, but it's also just a ton of fun. And I think a lot of people in our world are just curious and just want to know how things work. And so there's a lot of opportunity to do that.
Going from the not becoming a doctor to something else, having Chinese parents, I can definitely relate to how that feels.
So I was actually going to ask, you already shared some aspects of this, but what does a typical day for you look like as the director of engineering at Flatiron?
Yeah, I'd say my job varies quite a bit. I get most of my work done through other people or working with other people. So naturally, I'm spending a lot of time in meetings. But I'm generally just trying to find the right people, put them together, help them understand what they should be working on. I really love the management side of my job. I love giving feedback. I love giving positive feedback. I love giving constructive feedback, and I generally just like helping people see what they can do, and to help them get there, and then to help impact the business. And I've been lucky enough to work on businesses that I believe that what we're doing is also a good thing to do. So you impact the business, you impact the world. It's like it works out.
So I actually, one of my personal goals is to get better at giving feedback. I find it pretty difficult, especially constructive, right? Because I feel like usually you need to have social capital, you need to build a lot of trust before, and you also want to be very precise about the feedback you give, such that it doesn't feel like, oh, it's just a feeling, but it's based on evidence. How is that something that just came naturally to you, or is that a skill set like you develop over time? Like, what do you have any tips or advice for me?
Actually, I would say +1 to that question.
I mean, I think you nailed a lot of the things, right? Good feedback is specific and actionable and comes from a place of care. I think you're right that you can't just jump in and start giving people critical feedback when they don't know anything about you and they don't trust you. You have to get to that place of trust with people where they trust that you have their interests in mind as well when you're giving that feedback. So I wouldn't say it comes natural. I sometimes joke. My dad's an American football coach. That's his profession. So I certainly grew up in a household with probably more constructive feedback than most people did. My dad has no problem yelling at people. Obviously, I frame things very differently than that. But I think that I guess the where that really connects is I remember when I was a kid, and I remember coach kind of getting down on me for something I did on the football field, and my dad said, "Hey, if the coach is getting on you, that means he thinks you're good. It means he cares, because he wants you to be good for the team. If he was going to bench you, he wouldn't be wasting his time on you." So that's kind of where I learned to love and seek critical feedback myself, and I think that's helped me learn to see that in others and see how critical feedback is good for people. And to when you really know you've got it is when you've given somebody like critical feedback and it increases your relationship instead of costing. Obviously, you have to have a relationship first. That's not you can't use it from nothing. But once you've gone far enough, you can actually develop more trust with somebody by giving them critical feedback, because they know that you care and they know that you're willing to have an awkward conversation to help them out. And so it has to come from a place of caring.
I wish I had that wisdom when my mom was yelling at me when I was growing up, but probably would have turned out better.
I know we're digressing, but I have a follow-up on that. So one aspect is, well, when there's a feedback conversation, one aspect is giving constructive feedback and doing it the right way. I think the other aspect of the conversation is also on the other side, where the person is willing to hear the feedback and understand that it's coming from a place of care and this person wants me to improve. I'm assuming there might be situations where the acceptance of feedback is not immediate, or at least there is more around like, hey, why do you think so? How do you handle those conversations in that case?
Yeah, that's a great question.
Like, in my mind, like that's the first concern I have if I'm thinking about constructive feedback is like, what if this person doesn't believe what I say? How do you get over that?
Ooh, yeah, great point. And certainly when I was starting off as a manager, to say any of this came naturally. Also, I've screwed this up many times. It's probably some former reporter of mine could listen to this and go, "That guy was a jerk. What are you talking about here?" So it's something that I've definitely had to develop over time. I think there's a couple things that make it easier. One thing that's been really great is Flatiron has a really well developed. I think a lot of companies are getting better at this. We have a great career ladder. I know I really sound like a director of engineering when I talk about how excited I get about a good career ladder. A good career ladder is a beautiful thing. because you can point to things in that document. You can help people understand it over time. And like that really helps to sort of contextualize things. And that I think can make things more clear. And that helps a lot with the receiver of the feedback, knowing why you're giving them this feedback, how that fits in with the bigger picture, that sort of thing.
Got it. Really cool. Cool. So changing gears a little bit, here on the podcast, we love to, hear stories. Very excited to hear some of your stories today about recommendation systems going bad. Before we start, can you give us kind of a TLDR on what a recommender system is and how does it work?
Yeah, I love that. Because I think it's not as obvious as it seems. I mean, I imagine some people are like, oh yeah, recommender system, like Amazon. People who like this also bought this, right? And but I think there's actually a lot more to it than meets the initial eye. In general, a recommender system is, I think, anytime you have more items that a user could potentially engage with than you have attention for that user to spend finding something to engage with. So, the classic example is a little three boxes at the bottom of a product page that says, hey, if you liked this, you might also like these things. But it goes all the way up to, Netflix, they have a recommender system of recommender systems. They build that whole page, the list of lists. That whole thing is optimized all together, from what I understand. So there's a lot that goes into it. So a recommender system, in terms of how they work, they can be anything from a simple graph walk. Like I said, people who like this also like this. Even saying the words graph walk makes that sound more complicated than it is, right? Like you literally could just like look up, if you have that data stored, you could just look up whoever liked these other things. A lot of times you can model a recommendation algorithm as even just a classification problem. If I put this in front of somebody, will they click it? And then when the sort of next level up is you look at it as a ranking problem. It's like, okay, we have n number of impressions that we can give. How do we put the best things that this user might engage with into those spots? And do we just put the things we think they're most likely to engage with? Do we use that space to give them new things that we want to know if they're going to like them or not? Do we use that space to make sure they have a variety of options? Because maybe they're in different moods when they come to engage with the product. So there's a lot of different ways that it kind of comes together. My first ever job building recommender systems was at Orbitz. I built a little hotel recommendations module. So if you're looking at a hotel, we showed 3 other hotels that you might like. And one of the most successful algorithms we ever deployed for that, we found a hotel that was similar to the one you were looking at. We found a hotel that was at least $20 cheaper than the hotel you were looking at. And we found a hotel that was at least a star rating up from the hotel you were looking at. And it was this sort of Goldilocks sort of scenario from whatever buying psychology land. And that was one of the most successful algorithms that we ever did. Was kind of, so recommender systems nowadays, I'm sure you'd be doing all sorts of personalization and machine learning for that. But even just sort of that handcrafting thing like really played a role in making that successful.
Nice. So speaking of Orbitz, our first story starts with the Wall Street Journal article from a while back called "Orbitz Steers Mac Users to Pricier Hotels." So what happened?
So I can't remember the exact details, but I think the first version of that headline was even worse. I think the first version of that headline really made it seem like Orbitz was actually charging Mac users more. So my story for this is strange because I was actually not at Orbitz when that article came out. I was in my first week at Meetup. So I had just left Orbitz and I'm not there. And so I can't speak to the response or what happened inside or anything like that. But I just remember like I just moved to New York City. I'm in my new office. And now there's this national news story. This thing, like Wall Street Journal published it. The next day it's on Good Morning America. This was, honestly, looking back on it, this was one of the first big, like, is tech bad news stories. Like, it's crazy to think about how, like, that's a whole style of journalism now, but, like, this was one of the first kind of big ones, I think. The story as I know it is that we had a group, the team that I was working on, I was a junior engineer, pretty much a couple years out of school, fresh out of school. The team I was working with was exploring different data points that we had available to us. A lot of people browsing orbits are not logged in, so we can't necessarily tie you to your user history and all that. It was hard to tie people to user history anyways. Like I said, we were rolling our own Hadoop clusters and doing our own thick tracking. It was hard. It was hard. But the one of the things that we had available to us was the user agent. So we had we knew your operating system, your browser, and that sort of thing. So like I said, I was working on that hotel recommendations module, basically three boxes at the bottom of your hotel screen. And we did a A/B test of basically doing that kind of very simplistic graph walk algorithm where we took the hotel you were looking at and we looked at people who looked at that hotel, what hotels did they end up booking? And we showed you the hotels that people were most likely to book after looking at the hotel you're looking at. And then we thought, oh, well, we know this user agent. Maybe we can segregate the data that we use. So for Mac users, we'll only use Mac data. And for PC users, we'll only use PC data. And we had some reason to think that might work because we had done some data analysis that had shown that Mac users tended to spend, like on average, 20 or something. Maybe it was a lot. It might have been like $100 more per hotel on average, hotel night on average. So we knew that Mac users, and this makes sense. A Mac was 2, 3, 4 times as much as a PC. So that kind of made sense, fit with our intuition. We deployed the algorithm, and it failed the A/B test, so I turned it off. In hindsight, I think the fact that the user had already clicked on a hotel, they pretty much already given us their price point when they clicked the first hotel. So they'd already given us more information than their browser was going to tell us about how much money they were looking to spend on this room.
Interesting.
Night. So the flip side then is I think I don't know who it was at Orbitz or whatever, but the sense I get was that the Wall Street Journal came in and was like, hey, we'd love to do a story on you. And Orbitz was like, oh, cool, we have this team doing all this really cool data stuff and doing all this really smart stuff with data. And, here's one of the cool things we found is that, people on Macs spend more on hotels than PC users do. So we're using that to to influence our algorithms or whatever. I think the article implies that it was used in search. As far as I know, it was never used in search. As far as I know, the only time we ever used it was in that recommendation engine A/B test that lost and I turned off. And it was national news story. Like I said, it wasn't like Good Morning America. That's a crossover. That's a cultural touch point. That's not just the tech or business world.
I feel like one of the takeaways for me is kind of ties back to what you were saying before about can't know enough statistics, because I feel like a lot of the concepts in stats it's not super intuitive, but it takes time to become comfortable with the concepts. Like here, I don't know, causal inference is the reason why sort of that gap in terms of like how we're using it versus how, journalists are perceiving it. But I definitely see those kind of discrepancies pop up and then it kind of causes mass confusion in terms of like, okay, what's happening here? So that's really cool.
The takeaway I've always had from it, I think that's totally valid. The other takeaway that I've sort of reflected on over the years was that the problem was, I suspect whoever shared this information with the Wall Street Journal, they did so willingly, by the way. They thought it was going to be an article about how smart and cool what the team's work was. And I think the problem was it was about how smart and cool the team's work was and not about what value it was providing to the customer. And so if you frame something as the value that it's providing for someone, it's a lot harder to be accidentally taken as, oh, we're tricking people or we're doing this thing to scam people. So I've always used that as a motivation to continue keeping the customer in mind.
That's really well said, because then you're not just distracted by sort of the shiny the algorithm without looking at what actually comes out. Any other stories along these lines?
So at Meetup we had a couple that I enjoyed. One of my favorites regards Schenectady, New York. Have either of you ever heard of Schenectady, New York?
Nope.
I haven't.
So Schenectady, New York is a small town essentially right outside of Albany, the capital city of New York. And Schenectady, now that you've heard of it, I bet you'll see it somewhere someday, because it frequently pops up anytime you're looking at cities and when you're collecting your geography data in a certain way. And so I'm not giving it away just yet in case you or the listeners want to try and figure it out. But so I'll give you an example. We did the first time I ran into Schenectady, we were just trying to figure out what are the biggest cities for using Meetup in the country. So pulled like census data and then took our data, divided it, and Schenectady pops to the top. There was a higher percentage of the population of Schenectady were using Meetup than anywhere else in the world. I've seen this as well. Do you remember Ashley Madison? It's like a dating website that had some sort of...
Oh yeah, the adultery thingy.
I think that was the gist. I'm not deeply familiar or anything, but I
thought that was a trick question there, but okay, I see you.
I saw a news story once that said, what are the top cities for Ashley Madison users? And it was like LA, New York, Schenectady. So this pops up. Any guesses? Have you figured out why this happens yet?
Are a lot of the things being routed through it? So it's like the data is collected there, even though the users are not actually there. Is it something like that?
That's a good guess. So the trick is it's actually user generated data. And it's user generated if you ask the user for their zip code. Because a percentage of people, when you ask them for their zip code, are going to type in 12345.
Is that the actual zip code for the city?
So it's not even the zip code for the main city. It's actually a zip code for a GE plant that sits in the city. And GE got this. It was like an honorary zip code. The background of the story of zip codes is fascinating, but they didn't used to exist. And now they're like the main way a letter gets to where it's going. Like you could write anything you want as the city, but if you put a zip code, that's the post office it goes to. So GE was given this honorary zip code when they were first giving out zip codes, I guess. And now they have to staff this huge mailroom because anybody that puts 12345 on a letters to Santa, like they all end up at this mailroom at GE.
I feel bad for GE here.
A friend of mine was actually a journalist at Albany at one point, did a whole story on this and like interviewed people in the newsroom and stuff. But yeah, so keep an eye out for Schenectady. It's really just a parable of make sure your data is clean and don't trust user generated data. But yeah, there's a lot of... Sorry, go ahead.
No, that's actually kind of cool because part of it is sort of, how you discovered it is sanity check, right? It's like you've done analysis and then it doesn't... And I think, that's kind of a commentary to a lot of, machine learning products or problems you want to solve, right? Because I can imagine, me working on this 2 a.m., filling a ticket, and then it's like, oh yeah, let me just pull up the top 10. And then, all right, looks good to me. Do you like have sort of a process in terms of like other than just because I think you do have to care a lot about the problem and also having a good standard to your work, right, in order to like examine these things. This case it could be very obvious, but sometimes it's more subtle. How do you? I'm curious, like how do you kind of go about getting people to do like a lot of sanity checks?
Yeah, good question. One of my former coworkers, Randy, I think he's Randy_AU on Twitter. He's a great follow. I think he has always described his job as either counting things or data cleaning or something like that. And one of his constant refrains is know your data. And so if you're going to be trying to do something with data, you can't spend too much time getting to know that data. And often the best way to get to know data is just, run some top tens, check it out, check how long does the tail go, check the bottom of it. And just, know what you're working with, building up that intuition. And like we said earlier, this is one of the big challenges with a place like Flatiron. It's very hard to get to know a bunch of insanely complicated cancer data. But it's really the only path to building up that intuition. And it really becomes a sort of superpower of being able to understand what am I expecting my model to see, because I know the kind of underlying data and what that means.
So before Flatiron, you led the team at Meetup, and I can imagine one of the core ML problems there, right, is how do you recommend the best meetups for users? And I think you were telling us like one of the times this didn't exactly happen as intended. What happened?
Yeah, so at one time, my team put out an algorithm change, and we had a pretty good workflow, so we could launch stuff pretty quickly. And we put out a change. I probably code reviewed it myself. Looks good. And we ended up reversing our recommendations. So the way we did recommendations at Meetup is we would select all of the Meetup groups near you, it's geography bound. We'd find all the meetups near you, and then we had enough time. Our algorithms were fast enough, and our model was simple enough. We could score every meetup in your area, and then just sort them and show you the top 3 or 5 or however many spots we had on that page. And we could even reverse that and say for a given group who are the people that are most likely to join, and that's who we would email when a new group started. So using basically the same algorithm. But yeah, at one point we accidentally put out a change that reversed the order, so we were literally showing the mathematically worst meetups for all of our users. And most of it didn't reveal anything too deep about the psyche. It wasn't like we found who was the opposite of you. It was mostly just showing kind of the most garbage things on the site, the most empty things or the most sort of weird spammy things or that sort of thing. Which was good. It actually made us feel really good about our recommendation system. We were like, hey, I think this thing's actually working. Because we're looking at the bottom really tells you something.
Yeah, and how did you guys discover the problem after?
I think we just discovered it just by looking at the recommendations. I don't think we had time to notice from the user engagement. We had a lot of graphs about how much are people. All of our A/B testing stuff was all tied into the systems, and so we monitored them constantly. I mean, it was a relatively small team, and the all the tools that exist today didn't quite exist yet, and so I just spent a lot of my life in Graphite, just looking at graphs of how things were going. But I don't even think we noticed it in the monitoring, because I think somebody pretty immediately noticed. They were like, "These look bad," and I think we knew enough about the release that had happened to have a guess as to it was probably that code, and then pretty quickly figured out that oh man, we just literally the minus sign on this.
Kind of extrapolating on that. So for software, I feel it's more straightforward to monitor for when something breaks. Austin is not here today. Otherwise, he'd be rolling his eyes at me, I think, at that statement, having worked on monitoring infra. But you get an error, right, at the end of the day, usually, compilation or runtime or something else. But then for ML, I do think it's a lot harder because everything can compile just fine. But then, the model can be spewing out sort of total nonsense. I think there are easier cases, right? If you're trying to catch fraud and everything is flagging as fraud, then, maybe it doesn't even pass your CI process. And maybe you add some kind of rule to say if this just looks completely out of whack, we need to stop. But for some of the more subtle sort of things, it becomes a lot more difficult. But I guess curious to get your thought around debugging some of these problems and things like that.
Yeah, I think one thought that brings to mind is related to just deploying machine learning models and using them in production and A/B testing things in general. One of the things that I think everybody who deploys ML models in a consumer scenario, especially any sort of recommender system or search or anything like that, I think a lot of people, I mean, maybe not everybody, I'm sure there's problems where this doesn't apply to, but a lot of people eventually run into a place where your offline model performance is not predictive of the online performance. And there's sort of a key, especially in this sort of user-consumer scenario, there's sort of a key reason why that happens, and it's users can't find a show that they've never heard of. In Spotify, I will never click on an artist that I've never heard of or that I've never seen. If it's never been recommended to me, if I haven't searched for them, if they're not related to another artist that I already listened to, I'll never hear about them. So there's no way I would ever find them. And that's inherently going to influence your model. So where your model just can't know, it can't know how people feel about things that you've never exposed them to. And so, and some level, any way you can get new information into a model, if you can expand the sort of, like I said, using that, take Spotify example, take an artist that I do listen to, and then find the other artists that are similar to that artist. Like there's a reason that these sort of graph walk things often become a component in recommender systems. So you're trying to find new things. But if you're approaching it as a strictly classification problem, will this person like this artist or will they like this artist? You can only know that I've liked artists that I've listened to before. And so your offline model might be great, and it's not going to necessarily work once you deploy it. And I think that's how most people learn this, is they get an offline model that just crushes it. It's like, oh, it's 5% improvement over the previous model, and you deploy it, no better. And then the flip side of that, you realize oh man, some of those models that weren't, maybe not slam dunks offline, maybe they would actually work if we deployed them because they used some new data source or they did something interesting. They had some new interesting idea to them. So that's one of the huge things. You have to test everything. Offline performance does not predict online performance, especially in a scenario where there's more items than anyone's ever able to interact with. I think you have to have monitoring around all those things. Monitoring, the click-through rate on your algorithms is super important. In the world that I'm in now, we don't deploy algorithms that are used by consumers, but we do have data sources that are increasing all the time. And so we are constantly retraining our algorithms against new data to make sure that they're still hitting the same performance characteristics that we expect, make sure we're not introducing new bias into our algorithms or anything like that. So there's a lot of different things, and it depends on the problem that your machine learning algorithm is solving. But I definitely think continually monitoring performance is an important factor.
That's really interesting. So would you say that a lot of orgs, I guess, undervalue the infra, like how important the infra piece, right? Because what you're saying, right, is that things might not work in offline as well in online. So we have to run everything through through prod. But then that means setting up the infra such that maybe you can test out multiple models and then, do your things. But then you also need to, if you're doing sort of a CI/CD pipeline, you also need to have really good testing coverage and, all these sort of things. And then, like you said, also monitoring, but that's also now trivial again, because you need to probably run through some samples, and then maybe you have a golden test set that you always run, and then you have to look at distributions. So, and then that feels like a lot of that just is just infra work, right? It's not ML specific at all. And is that something that I guess that's been the case?
Absolutely. I mean, I know that your backgrounds are in data engineering. I know a lot of the people that have been on the podcast come from the sort of infrastructure side, and you've talked to a couple of other people about chaos engineering and that sort of stuff. And I can't understate how important the infrastructure side is, especially A/B testing. But really, if you I know, I'm sure there's a bunch of different ways to go about it. I don't know. I've been out of this world for a couple of years, but I don't know if there's a product now that you should use for A/B testing and feature flags, and if all that stuff kind of fits together. But there's really a lot of overlap between those things. And so I think, trying to approach them, I hope everybody's not still relaunching their own. I swear I probably wrote 3 or 4 A/B testing frameworks in my career. I hope I don't have to do another one. But yeah, it's super important. And like you said, it's such a crossing over. It's such a intersection of the product side, building good monitoring. You got to know what's important about the product, the infrastructure side, the algorithm and data side. It all comes together.
So this is something that might be obvious for folks who work on machine learning, but I don't. So it's not obvious for me. But can you share some examples of how do you monitor performance of a model that's in production? For software systems, I know, counters, gauges, latencies. I can think of the obvious things, but what are some of those not obvious, or some of the obvious things in the ML world?
Yeah, I think most of the stuff is similar. You just count the number of people that interact with a given module, and if people are usually 5% of people on a page interact with this module, and all of a sudden that drops distinctly, you've probably got a problem there. One of the problems is that things are rarely going to go to zero, and sometimes a subtle effect can be. I saw a great talk from someone at Uber once who was talking about all the things they do to predict traffic and all the monitoring they put in to try and look for spikes in traffic and all this sort of thing, and down to the level of like, a Rihanna concert just got out, and so now there's a spike of traffic in this area.
Oh, wow.
And I thought that was really cool.
Yeah.
And that I never got around to building like that good of a system, but that's what I'd love to have is like basically over time, what are the fluctuations in engagement with this module? Because, it's going to vary by location and by all these features. And that's what makes it really hard to detect. Like you could tank your algorithm in Texas, but if that's 1% of your users, you might not notice that difference in your metrics. You might just think, there's not many great, things this weekend, or maybe it's a holiday. Like it's very hard to tell the difference between a holiday or some other thing where the engagement goes down. So yeah, there's no unfortunately like easy playbook that I know of for like, here's the things that you need to make sure you're monitoring this well. But there's definitely a lot of things you can take into account to get to the ideal system.
So being on the infra side, I love the fact that you're talking about monitoring and you actually care about it. In the infra world, we usually have like, hey, there's a production checklist you have to go through before launching something in production. And one of the things actually is, do you have metrics that you can monitor? And if the system goes down, you need to know. You don't need the customer to find out that your system went down. Do ML teams also have similar, if not checklists, but similar procedures to say, well, before shipping the model, you have to make sure you have the right metrics you're looking at?
Yeah, I think there's I think especially on this more than anything else, at least like I said, coming from the land where our data engineering team and our ML team were the same team. We were called the data team, and we had to do both because, we were the team that wanted to start tracking clicks so that we could use it as a feature in our recommendation algorithm. So we had to build the data warehouse to be ordered to store all those clicks somewhere. And so we always wanted, we wanted to track and monitor everything because, if you can monitor something, then hopefully you're keeping track of it. And if you can keep track of it, then you can, hopefully use it as a feature in your model. And so I think there's a lot of overlap between those things.
That's pretty cool, actually. You're right. I remember you were talking about this. So having a team that's composed of both sort of people working on ML, but also data, because it is so tied together. How is that your general philosophy in terms of like for most like ML teams to, because right, one issue I can imagine is getting people that are specifically working on ML to care about both the production aspect as well as like how the data is created, but then also pushing people who are working on data to also care about like, hey, where are you going to shove all these data into, right? Has that been a challenge or?
Yeah, and I've already tried to make the case that I really want to hire machine learning people who really deeply care about the product space as well, right? So now you need to care about the infra side and the product side and the data and the machine learning. So yeah, it's definitely hard to cover all those things. And I think composing teams of people that care about different aspects of that and can share that with that knowledge and interest with other people. And, it certainly as you scale, like most of the lessons that I learned came from working at Meetup, where we had a pretty small team at times. It was like 3 of us probably at one point up to, maybe 10 by the end. But like, so it was pretty tight knit. We knew who cared about what. And it was pretty easy to remind somebody like, hey, you got to let me know when you're doing that thing because I need to do this other thing. And it's hard, and I don't know the answers to how to scale this up indefinitely. Certainly, the really big organizations that seem to do this very well, obviously your Facebooks and your Googles, they just have a ton of. There's a reason why we get paid to do what we do. It's because there's a limited number of people that can do all these things, and Google wants all of them if they could. So it's it's hard to find people that can put all these aspects together. But as you grow, then you can hire more and more specialized people, build more specialized teams, and try and divide out those problems. But it's definitely good to know at least a little bit of all of these different factors, at least know they exist, at least know that somebody cares about them, because then you hopefully won't have a gap in your approach.
And our last story, I think, is about you're speaking at conferences about racist and sexist algorithms, so model, fairness, interpretability. Yeah, tell us more. What happened?
Yeah, so after a lot of my experience working in deploying recommendation algorithms and that sort of thing, I put together a talk called When Recommender Systems Go Bad. And I went around talking about a bunch, basically had examples of times where companies had built algorithms that then turned out like, oh, you trained an algorithm on Twitter data, and now it says a bunch of racist stuff. And it's like, well, yeah, you probably shouldn't have trained it on a bunch of racist data. But then, from there all the way up to like really scary stuff, like models for predicting recidivism, like basically models that predict whether someone that's been in jail is going to commit another crime, and how these things can be impacted by race and stuff, whether it's out of ignorance or whatever, like that can happen. And it's, in fact, I think as someone who builds machine learning algorithms, I think we need to have this top of mind in our day-to-day and really think a lot about how, is this model going to be biased, not just in the ML sense, like we talk about bias in the machine learning sense of like, over relying on certain data or whatever, but biased in the societal sense. And, one of the problems with that is that society is biased. And so it is hard to pull that out of your data and get your model to not learn it and to not perpetuate that. But I used to end all my talks by saying, racist computers are a bad idea. Don't let your company invent racist computers, which feels pretty, I think most people would agree with that. But it's hard to figure out how to do that. And so I never had all the answers, but I definitely just wanted people to be aware of it and think about it and think how, like there's problems with society, and we probably shouldn't encapsulate that in our algorithms if we can avoid it. Now, did I always do this perfectly myself? Absolutely not. At one point, I think I'd already been giving this talk for a while, and I was at work one day and one of our community team members said, hey, I just got an email from an organizer, and they were kind of offended by the topic recommendations that they got. So one of the ways that we got around, trying to bootstrap our algorithms with data was we would have people pick topics. We had this big topic graph on Meetup, just things that you're interested in, snowboarding, knitting, whatever. And organizers who were starting a meetup group could pick what topics the meetup group was about, and users could pick what meetup groups or what topics they were interested in. And that's kind of the base way that we bootstrapped our recommender system. So the algorithm for this particular user, the person starting a meetup group was trying to start a group for women's business networking. Cool. And then the topics that we recommended, I think the organizer had picked like women business owners or something like that as their sort of core topic. And then from there, we recommended fashion, shopping, skincare, makeup. And that was probably pretty offensive to that person because they were trying to start a business. And we gave all these sort of generically like stereotypical topic recommendations. And so, looking at that, we thought, okay, what are the inputs in this algorithm? Why is it doing this? We realized that the topic recommendation algorithm was based on user preferences, not on basically what. So, the sort of classic graph walk, people who did this also did this, collaborative filtering recommendation algorithm. We were basing it on user preferences. So users that had picked women business owners were also likely to pick fashion, shopping, etc. But groups that were started about women business owners were not about all of those other things. And so we just had to change what data we were putting into that algorithm and base it on the group topic graph instead of the user topic graph. And then we got much less sort of stereotyping and gendered sort of recommendations. But these things are hard. There's no you can't predict all the different ways that it'll happen. That was one of the times where I had to.
It's so interesting that, I mean, what goes in comes out. In this case, you mentioned that an ML model can reflect the reality of the society. The biases or inherent biases that exist in the data itself will come across even though unintentional. There's the other aspect to it as well, where a lot of the information we consume these days is through recommendation systems or systems which are powered through machine learning, like the movies you watch, the news you read, the ads you see, like all of it. So it also creates this information bubble around you where it kind of influences the way you see the world on a daily basis. How have you, or do you have any other thoughts on this in terms of like, how has this information bubble been affecting the society? I mean, we don't have to talk about the elections that happened over the last 4 years. There are a lot of documentaries about that. But in general, like, how as an industry are we even recognizing that, hey, there is a problem which kind of we created for ourselves, even though unintentionally? How can we make that better?
Yeah, it's such a tough question. I think, algorithms are just designed to maximize engagement, right? Everybody just wants people to like their website and use it.
Yep.
Because that drives ad revenue or whatever, to solves whatever thing you're trying to do.
Yep.
I think maximizing engagement is not an algorithm-only thing, right? Yeah. So newspapers are trying to maximize engagement. TV networks are trying to maximize engagement. And so, when you look at certain TV networks or news sources or, online, some like whatever blog, like they're just trying to say things that their audience is going to respond to and share or engage with, whatever. Another great Twitter follow is Carl Higley. I've never actually met him, but I think he's the best follow in Rexus world on Twitter. So hit him up. He was just ranting about this like this week, I think, and saying that like maximizing engagement isn't inherently wrong. Everybody, like the newspapers publishing the story about how algorithms maximizing engagement caused all these problems. Those newspapers are also maximizing engagement by writing that
article. Absolutely.
So it's really hard to figure out where the solution is here. And I'm not saying at all that it's not a problem. If anything, okay, so an algorithm, we used to talk about a lot about the filter bubble. So kind of like what I said earlier, if you want to bring in other data sources to break someone out of, if you only ever listen to Led Zeppelin on Spotify, they don't only show you Led Zeppelin because they've gotten good enough at these algorithms to find the other things that you might like. But with the very basic algorithms, it was really hard to get you out of that filter bubble and only showing you the things that you've already sort of engaged with or listened to. So an algorithm that only ever shows you one type of thing is probably not maximizing engagement enough because it could probably show you other things. So the filter bubble and the information bubble, I think, slightly different problems, or at least they have definitely different solutions. I guess, if anything, I would say, I wish that media and news weren't so intertwined. I think that's one of the problems, is that like news and information probably shouldn't be the same sources as entertainment, because that incentivizes the news producers to be entertaining, or at least on the same, platform within, I'm sure we're all thinking of the same platform where people go for entertainment and end up getting radicalized. Mm-hmm. Not great. I also think that, one of the things that comes up on these, and I'm no expert on this sort of thing, but freedom of speech is the big rally. Like, these platforms are hurting my freedom of speech. Freedom of speech is not freedom of distribution. No. There's no yes. no rule that says YouTube has to promote either radical stuff as much as they promote, whatever your favorite YouTube channel is. So I think as these platforms, if I was working on them, I would want to aggressively deprioritize any sort of hate speech, any sort of racism, any of those sorts of things, because there's no law that you have to promote those things. You don't have to guarantee those people a platform.
It's so interesting. Like a lot of recommendation systems or any of these algorithms to improve engagement are in one way for information discovery. where it's like, hey, you have way too much stuff you cannot go through. So let us suggest what you can go through to be on the platform. And there is a show on Netflix, which we don't want to talk about, but it was like portrays all these social media companies as evil. And I feel that it's giving tech too much credit. I don't think we thought this through, that, hey, in the next 10 years, when we have all these amazing platforms with internet being ubiquitous in the entire world, we'll have these control over the society in general. Like, we can control opinions, we can show them the world which you want them to see. And I feel it's too much powers in the hands of engineers who are writing code on every single day without realizing the long-term impact of what they end up creating. If nothing else, at least I hope the tech industry I think this conversation is happening, which is a good thing, but we realize and recognize that, hey, this is a problem. And if nothing else, we at least need to be conscious about what we are building. And just optimizing for engagement is not the only metric that's going to help us grow.
Yeah, and I think sort of a side note to that, to me, I feel like the contrast, I really like how you put it, Evan, which is that, in the tech world, like they have the same objective functions, right? Which is to say maximize, retention or some like click-through rate or whatever. But then in the old world, like without tech, I think there's a lot more sort of qualitative checks along the way, where like, oh yeah, like maybe this is an idea I have, I'm going to implement. But then as I'm doing it, I realize, because it's a person at the end of the day that's doing that, right? Versus in the computer world, once you very specifically say what your objective is, you kind of, unless you specifically add also like, right, checks and guardrails, otherwise you would just literally do what you tell it to do, which is to do that. So I feel like that aspect as well.
Yeah. And that was something I was trying to, part of that, or one extreme of that attitude is something I was trying to fight against with the talk that I used to give about societal bias in algorithms, which was, so the example we used at Meetup, and something I was very proud of, was we made sure our algorithms didn't explicitly combine like gender and interests. The sort of key example for us was coding meetups. So if you were to look at coding meetups on Meetup, yes, a higher percentage of men were interested in coding than women. But we didn't believe that we should let that impact who we showed coding meetups to. And we decided as a company, we didn't want to look at gender that way. And so we took a stand. And so we used that idea, that value that we held to choose what our algorithms did. And what I definitely can't abide are the engineers that say, oh, well, that's suboptimal. Wasn't it suboptimal to not show coding minutes? Like, maybe, but like it mattered more to us to do what we did. And so I think the same thing is what I would like to see. And if I was working on those platforms, at least, it's hard to know all the factors, but I would want them to take a stand and say, actually, we don't let this kind of hate speech or this kind of ideas propagate on our platform, and so we bake it into our algorithms to not do so.
Thanks for sharing that stance. I don't think it's easy to take that stance openly, so we appreciate that. So going back to one thing, so I was recently in India. I was meeting my family, and my mom has started using some of these social media systems, and she was like, "Hey, it's amazing! She recently became friends with a few of our relatives, and she saw other people being recommended to her, and she was like, this is pretty cool. How is it doing that?" My family's not into tech, so how do you explain, well, let's just say, a recommendation system to someone who is not in tech? Like, explain it to me as if I have no idea about, or I'm a 10-year-old child.
Sounds like an interview question.
No, I'm just trying to figure out, like, how can I talk to my family or use some vocabulary that is, because if I go and say it's a recommendation system, they're like, well, what's a recommendation system? And I was like, it takes too much words to explain. And I'm like, there should be a better way of doing it.
I think where it gets really tough is when somebody says like, "Oh, is my phone listening to me?" Because the other day
all
I
the
said
time.
wallets, and now I keep seeing wallet ads, and I'm like, I don't know if it's listening to you. I hope not.
Oh, so this happened. Like again, this happened recently in India. Some of my friends had an assistant in their home, and they interact with it through voice. And they're like, "Oh, is this listening? I see this ad on Instagram," and I'm like, I don't think it works that way. But yeah, anyway.
Hope not.
Yeah.
As far as how to define a recommender system, yeah, I mean, I think the easiest way is probably just tell them collaborative filtering. If they're just no, but the easiest way is that sort of like, oh, they know that you're friends with so and so, or like, you're friends with 5 people that are also friends with this person, so that's how they can guess that you know them. Now, the truth is, it's probably a lot more complicated than that. Maybe they have access to your contacts in your phone because you installed the app, and they know that you have a contact for that person already. Like, the number of factors that could be weighed in are a lot, and honestly, not everybody knows all those factors and might feel a little, the companies that are building things don't necessarily want everybody to be completely aware of all those things, so they'd have to explain all that. And part of it's just hard, and for the most part, we get used to these things as we go along. Like, people used to freak out that they looked at looked at some shoes, and then a week later saw an ad for those shoes. We've all accepted that by now, right? Yeah. Everybody has some sense of like, oh, it's cookies or whatever, right? But yeah, it's hard to know what the right line is, and I think we're getting better and better at transparency, and as users understand more and more where they want to draw that line, and so, yeah, I hope we're moving in a good direction on those things.
Makes sense. So we're starting to wrap up. And I have one question that is probably a little more personal as well. For folks who don't work on ML yet, but are interested in dipping their toes into it, do you have any advice?
I love this question. So on one hand, there's tons of ways to go and get exposed to ML and learn some of the techniques and do practice problems. And there's Kaggle, there's so many great ways to go and learn machine learning now, and I think that's all awesome. If you're hoping to do it at work, if you want to do it in prod at your company, I think the coolest sort of route, or the most effective route, is to come at it from the problem side. So you know something about a problem that you have that your team is trying to solve, whether it's a product problem, whether it's an infrastructure problem, any of these sorts of things. You know more about the problem than somebody else is going to. Maybe you have a machine learning team already. Maybe you don't even have anybody at your company that does machine learning already. So thinking about solving the problem first and using your knowledge of the problem is going to be one of the best sort of angles into it. And try not machine learning first. That's the key. I tell that to every machine learning engineer. What's the first thing we could do that's not machine learning? So try those things first, and then, but at some point, maybe, there's a reason machine learning exists and is so popular, is because it can solve problems that are hard to solve without machine learning. So, I would say do that first and use your knowledge of the problem. If you do happen to go to your machine learning team or something like that, and want to maybe co-deploy a machine learning algorithm for the problem that you're trying to solve, I would say one of the big things that most machine learning folks have is a lot of scar tissue around getting burnt by machine learning algorithms. One of the things that you learn is, oh, this algorithm has 99% accuracy. Awesome, I cracked it. And it's like, no, you didn't. You broke it. You put data in that it wasn't supposed to know. And constructing the problem of how you ask a machine learning question is a really hard thing to do. And this is the worst thing you could do is go to your ML team and say, hey, I wrote this algorithm and it has perfect performance for my problem. Can you help me deploy it? And they're like, first of all, I like making the algorithms, not deploying them. So don't come and ask me to deploy your algorithm.
Yeah.
And second of all, it does not have 99.999% accuracy, because if it did, it probably wouldn't be worth doing with machine learning, or it's just broken. And so, developing that bit of scar tissue, a lot of skepticism about algorithms, figure out ways, the better you can understand your problem, if you understand your problem well enough to really know how to test the machine learning algorithm and see if the machine learning algorithm is working or not, that's a really good sign that you're thinking about your problem deep enough to go in and apply machine learning to it. So like my constant refrain, keep the problem in mind. Think about what you're trying to do, not just how you want to do it.
I love that advice. If nothing else, I'm going to send this hey, try something that's not machine learning first to a lot of people. Thanks for sharing that. And I can say it's coming from an expert. I am not the one saying that. We have a question which we ask everyone towards the end. It's what was the last tool you discovered and really liked?
Ooh. I certainly didn't discover it because probably the answers that I need to give to this are things that have existed for a very long time, but I'm like finally getting a little good. I can finally write an awk command and get it right the first time, like every once in a while.
You're a better engineer than I am.
I mean, only simple stuff, only like print column. Nothing crazy. But that feels really good. I feel like that's a bit of a power that I've been learning. I also really like, I think it's called process substitution, where you do like angle bracket parenthesis, and then you can put in a whole command, and it takes the output of that command and treats it as if a document. It's like having a named pipe. So sometimes it's just a lot easier to construct. I feel I always struggled using xargs, and so for certain types of things, I find it way easier to just treat it as if I had a file on disk, but I don't want to write the file somewhere. I just want to like take this file and then, put it through sort first, but then treat it as a file in the command. So that's what I'm going to go with. I'm going to go some real command line junkies.
Wow, Evan is really trying to impress our audience.
Yeah, we love Bash.
Is this good for this audience?
Oh, yes.
Nice.
It's the best.
All right.
Yeah. Nice.
Anything else you would like to share with our audience, Evans?
I guess I would say to people trying to construct their careers, this is just one of my favorite things I like to tell people. You can't go wrong working with people that you like on things that you like, but you especially can't go wrong working on things that you believe in and things that matter. And so if I could have any influence on the tech landscape, I would say go work on problems that matter, things you believe in. It's going to be good for your career. It's going to be good for your feeling about how you do things, and it's going to be good for the world.
Oh, that's great advice. Thank you so much for taking the time, Evan. This was awesome.
Thank you so much.
Yeah. Thanks for having me.
Hey, thank you so much for listening to the show. You can subscribe wherever you get your podcasts and learn more about us at softwaremisadventures.com. You can also write to us at hello@softwaremisadventures.com. We would love to hear from you. Until next time, take care.